Okay, global warming. Also, we want to focus more on global climate change. So we don't want to focus just on the warming potential of the Earth, but we also want to focus on the extreme weather conditions. So the greenhouse gases are the ones that absorb infrared heat and trap in heat so that it warms the troposphere. These are water vapor, and this is the most abundant greenhouse gas, but it's not as persistent in the atmosphere as carbon dioxide. Carbon dioxide is the molecule that we use to measure all of the other ones against, and we call that the greenhouse warming potential. Ozone, O3, at the troposphere is actually a greenhouse gas. Methane, remember ozone in the stratosphere, we like it there. Ground level ozone, bad. Stratospheric ozone, good. That acts as our sunscreen. Methane, CH4, nitrous oxide. And by the way, methane has 25 times more greenhouse warming potential than carbon dioxide. Then we have nitrous oxide, and chlorofluorocarbons are the only man-made greenhouse gas on this list. The greenhouse effect is good. As a matter of fact, we have to have some greenhouse effect. If not, the Earth would not be at a temperature that we could live. It would be uninhabitable. Now, the problem is that these greenhouse gas emissions have been increasing since the Industrial Revolutions. So NASA has been tracking data since 1880, and they all have seen that since 1950 there has been a huge increase in carbon dioxide emissions, and that the temperatures have increased since 1950 significantly. So carbon dioxide, methane, and nitrous oxide emissions are higher, and mostly this is because of agriculture, deforestation. If you think about this honestly, though, let's go back to population growth. The reason we have to have more agriculture is because of a higher population. The reason that we have more deforestation and habitat destruction is because of a higher population. And then we're burning fossil fuels for more energy that we need for the higher population. So there is a correlation that we've seen of rising carbon dioxide and methane with rising global temperatures. So these are all anthropogenic sources of greenhouse gas. Remember that it's human caused. The largest contribution of methane into the atmosphere are actually the gut bacteria, and that helps the livestock species digest plant matter. And you end up getting more methane if you feed, like cows, for instance, corn instead of grass that they're supposed to eat. Landfills that experience decomposition in low oxygen environments, and the production, storage, and transport of natural gas and pretty much petroleum products that methane escapes from. Some natural sources, though, this happens also. You have, like with methane, that happens, it's volatile organic compounds, so that's going to happen anyway. Your nitrous oxide, that's going to happen, that's going to go into the atmosphere because of the plant use of nitrogen, and the nitrogen-fixing bacteria are going to emit it as well. So we know what's happening naturally. The problem is that anthropogenically we're adding too much. And then carbon dioxide primarily comes from the burning of fossil fuels. Okay, so you'll see in blue, these are the things that decrease the temperature, and in red, those are going to increase the temperature typically. So here you have your plants and animals, your plants and soil organisms pull carbon dioxide out of the atmosphere through respiration, but when they are clear cut and burned, that's going to add carbon dioxide back into the atmosphere. Usually it's kind of it's kind of at equilibrium when you have your carbon dioxide coming out and your plants putting it back in because of decomposition and whatnot. And then the oceans, they usually remove carbon dioxide from the atmosphere for us. Problem is as these oceans get warmer and warmer, they absorb less and less carbon dioxide. What kind of feedback loop is that? Yes, that's a positive feedback loop. Thanks for answering. Okay, and then you can see over here, why would the melting of ice caps actually increase the temperature? Well, you're right. It increases the albedo, or decreases the albedo. So instead of reflecting out the ultraviolet light, it's actually going to absorb it, and now it's going to warm up.
Students, if you know.
So as the Arctic snow melts, you have less reflection, more absorption, and then you have to think that the sea levels surrounding, think about the properties of matter. What happens when water is heated? That's right, it expands. Gases, liquids, and solids. And when anything is heated, it expands. That's a basic property of matter. So when you have your sea levels increased temperature, that means they're also going to rise, and then it's going to even hit more land-based ice, and then it's going to make it melt even more. So what kind of feedback loop is that? Indeed, another positive feedback loop. Okay, comparison of measured temperature from 1860 to 2007 and projected changes. Basically, the reason that you see the difference in this band right here is that you have higher projections going this way and you have your lower projections going this way. And essentially, we won't be able to hit those lower projections. We won't be able to hit those lower projections unless the world halts deforestation, makes drastic cuts in the greenhouse gas emissions from fossil fuel burning power plants, factories, and cars. And then that lower temperature in the range is also only likely if the gas emissions, greenhouse gas emissions, falls by 50 to 85% by 2050. So that is probably not going to happen. But the overwhelming consensus is that human activities are the major factor in temperature increase since 1950. And again, this data comes from NOAA. Melting of Elastic's Muir Glacier between 1948 and 2004. This glacier has receded so much that you've had pioneer species that have cultivated this rock and turned it into fertile soil to grow. Now there's trees growing there. So enough time for primary succession to take place. The big melt, some of the floating sea ice in the Arctic Sea, you can see where it was in 1979 and where it now is in 2007. And this is problematic because this is home to a lot of species that rely on this sea ice, especially your polar bears who they find the holes. The seals, what they'll do is that the Arctic seals will find a hole to swim up to get air, and that's how the polar bears will catch their prey. And then not only is it important for the polar bears, but the Arctic fox relies on the carcass of the seal that the polar bear leaves behind. So it's multiple species that are impacted by this habitat loss. Another thing it's important to remember is that as this, if it's land-based ice, if land-based ice melts, the water has not been displaced yet, so that will increase your sea levels. Remember, if it's already in, like an iceberg, if it's already in the water, then it's almost like thinking of ice cubes in your glass of water. When ice melts in your glass, it does not change the volume of your water because it has already been displaced when you put the ice cube in. So if it's already in this open sea, it won't change it immediately, the sea level. But you got to think, as it warms up, it will, because molecules expand. And then as they expand, then it's going to be able to reach more and more of this land ice. Sea levels are rising, so the water itself is expanding, and the melting of land-based ice. Greenland, why is Greenland significant? Well, it survived from the last ice age. It's very, very thick. It's actually 2 miles thick, and about 80% of this mountainous island is covered in glaciers. So it's the largest island, 80% composed of glaciers. 10% of the world's fresh water is held in Greenland as frozen. From 1996 to 2007, the net loss of the ice doubled, and the concern is the effect. So the sea level is sure to rise. And the other problem with the net loss of the ice is that there simply isn't as much snowfall to replace the ice that's being lost. So you can see here the areas of glacial ice melting in Greenland during summer from 1982 to 2007. You can see that this area has been dramatically increasing the amount of melt. And if this net melting of Greenland's land-based ice continues over a number of decades, the world's average sea level is going to rise. It's going to rise sharply. This is what will happen then. It's going to impact a lot of your low-lying islands, such as the Maldives. They say that according to 2000 IPCC report, the world's average sea level is very likely, with about 99% certainty, to rise 18 to 59 centimeters during this century and then keep rising for centuries to come. And majority of this, though, is going to be because of an expansion of the water as it warms, remember, because the basic properties of matter, and the rest of it's going to be because of the melting of land-based ice. And also, you can't forget about the mountaintop glaciers, not just the sheets of ice. So how does this impact us? Well, you see areas here of Florida that would, and of Alabama. You can see a little bit over here. That areas, a little bit of Georgia right there. Areas that would flood if we were to raise the sea level by 1 meter only. So some of the most severe consequences that could be observed are ecosystems collapsing. Some concern like even in Russia with the boreal forest, as that Arctic tundra melts, not only is it going to release methane into the atmosphere, but the caribou are going to lose rangeland. Some people say, well, hey, at least we're going to be extending the agriculture or arable land farther north, but that's not really the case. This is not fertile soil. Some low-lying cities might become flooded. The entire island chain of the Maldives would be affected by even a less than 1 meter change in sea level. Okay, so by flooding these low-lying cities, and even in just increasing the sea level would basically affect, you'd have saltwater intrusion, and it would degrade some of the coastal estuaries, wetlands, and coral reefs. Our fisheries will be affected. Wildfires, there'd be more wildfires in the forest. There'd be prolonged droughts. Therefore, your grasslands that are usually very fertile become dust bowls. There'll be more destructive storms. They've had some data where they're looking at the storms that we've had recently. Some of the hurricanes that we've had, they've been much more major, and a lot of the monsoons that we've had that have been more major. And then they're concerned with the glaciers shrinking, and the rivers, remember, rely on the glaciers and the mountaintop glaciers for their spring melt and spring rains in order to increase the river flow, which help a lot of the animals and species with their spawning and mating rituals, and therefore a lot of the rivers are drying up. Governments can enter international climate negotiations. This is the Kyoto Protocol. Now, the Kyoto Protocol was the 1997 international treaty. It was to reduce emissions of carbon dioxide, methane, and nitrous oxide to 1990 levels by 2012. There was consideration of trading the greenhouse gases emissions among countries, kind of like a cap and trade model. So phase one of the Kyoto Protocol went into effect in February 2005, and 174 of the world's 194 countries ratified the agreement by mid-2008. So they're trying to get the 36 participating developed countries to cut emissions to about an average of 5.2% below the 1990 levels by 2012. So it actually was signed by the U.S. We just did not ratify it, so we need to change that right there. And the reason behind that is because it would hurt the economy, because U.S. they wanted us to decrease ours by 7%, when the developing countries, the argument was that since we were the ones that increased our carbon dioxide to the point where it is right now, the concentration that it is, well, it wasn't fair for the developing countries to be penalized when they hadn't hit their industrial revolution yet, when we were post-industrialized. So they pretty much said it wasn't fair, but our government thought that, well, if they don't sign it, then it's going to put us it's going to pretty much put us behind. So the Kyoto Protocol for phase one did not require reductions for China, India, Brazil, Indonesia, and other developing countries. So a majority of Americans feel we actually should sign it. We should lead the way, and since we are so advanced in creating a policy that would be beneficial for all. But recently, the U.S. government actually has taken stronger steps to regulate carbon dioxide emissions, and the U.S. Supreme Court in 2007 ruled that the EPA not only has the authority to regulate greenhouse gases as part of the Clean Air Act, but they are actually required to do so. So that's when 2009 the EPA announced it's going to start regulating greenhouse gases for the first time, and a lot of the proposals were to increase fuel efficiency for automobiles, and that actually did get a lot of support from the automobile manufacturers, because it would allow for a 30% reduction in carbon dioxide by 2016, and the fuel efficient cars are supposed to cost an extra $1,000, but the reduced consumption of gas is going to save you, the driver, $3,000 over the lifetime of the vehicle. So it's actually a win-win situation. So this would also allow the United States to reduce greenhouse gases and invest in new automotive technology and reduce its consumption of fossil fuels. So the most recent data I have is that as of 2010, 190 countries now have ratified the Kyoto Protocol, and most developed and developing countries. We're still the only developed country that hasn't ratified it yet, but the carbon dioxide emissions have been mixed, the actual implementation of this. So some greenhouse gas emissions have increased in Australia by 119%, 57% for Canada, 17% for US. So we're actually doing better than Canada and Australia. But they've actually declined 21% for Germany, 4% for Russia. And so for all 41 developed countries, the reduction has been 5.2%. So that's pretty good. So in December 2009, in Copenhagen, they met there again, but they still couldn't agree on a legally binding carbon dioxide reduction moment. But, you know, a lot of the mayors in the United States, they actually got together and they felt like, well, we may not be able to do this as a nation, but we, the leaders, we could possibly get together. And so they did, and they came up with some of their own regulations. They are themselves going to try to beat the 1990 greenhouse gas emissions within their cities, and they're hoping that the entrepreneurial spirit of the American people will show. And California has been the leaders in this, and Governor Schwarzenegger, he actually in 2006 signed a bill, and again, it was to reduce the greenhouse gas emissions with the hopes that people would come up with some solutions and small business owners would thrive and create jobs. And they wanted to prove that by decreasing greenhouse gas emissions does not hurt the economy, but quite in contrast, it would actually stimulate the economy. Okay, so some people against this think that it's just the hotter sun because the sun is a star, but if that were the case, then the stratosphere would warm and the troposphere would cool. Instead, it's the opposite. A hotter sun would be warming your stratosphere because, remember, stratosphere, the ozone layer is on the bottom part, so the upper stratosphere would be hotter, and it's not. There is uncertainty about the effects of cloud cover on global. So we know warmer temperatures are going to create more evaporation of the water, and therefore that's going to, of surface water, and therefore that's going to give you more clouds. So it just depends on what the clouds are actually made up of, like on the content and reflectivity. The additional clouds could either increase, if it's thick, continuous light-colored clouds at low altitudes, that would decrease surface warming because it's going to reflect more sunlight back into space. But if you increase the thin, discontinuous cirrus clouds at high altitudes, that would actually warm the atmosphere. And by the way, they also think that some of the jet streams, the condensation trails left behind the jet planes might actually have an impact on temperatures and actually increase temperatures. So air travel's increasing so much, and they don't know the problem how to fix that problem unless we start using hydrogen fuel. Extreme weather will increase in some areas. Some areas are going to have higher heat waves and more droughts, especially if you're already drought and heat prone. You're going to have some areas with monsoon-like rains and flooding, and some areas that shouldn't have any rainfall at all, who therefore, once you do have flooding and prolonged rains, you'll get a lot of landslides. So more studies are needed because there are a lot of scientists who predict that the storms are getting worse, and perhaps that's why Hurricanes Katrina and Rita were so powerful. Global warming is a major threat to biodiversity. Most susceptible ecosystems are coral reefs. Remember, coral reefs can be impacted by a simple 2 degrees Celsius change in temperature. And they're also impacted by changes in pH. The amount of light that they get. They're just very sensitive, and they're home to a lot of biodiversity. Polar seas are also very susceptible because your poles are the ones going to be most impacted by global climate change, more so than the tropics. Coastal wetlands will either be submerged or dry up. High elevation mountaintops, you'll lose a lot of your glaciers, your mountaintop glaciers. Your alpine and Arctic tundra will melt. That will release methane, and you'll lose even the sea ice in the Arctic. Some of the sea ice is going to melt, and that's basically destroying habitat for some unique species that live there. There's a lot of concern even just that the global warming could disrupt biological clocks of birds and whales and other migratory species. So basically, they'd be putting them in the wrong place at the wrong time. So they'll be vulnerable for food shortages. They'll be more vulnerable to heat waves, droughts, cold snaps, and all that with accompanying climate change in various parts of the world. So some forests are unable to migrate fast enough to keep up with climate shifts, and those are going to decline. And others, like the oak pine, oak hickory in the U.S., might expand northward because of the drier conditions, and forest fires are going to increase because of the drier conditions in the southeast where we are. And that can degrade some of the forest ecosystems, which is then going to add more carbon dioxide. So it's another positive feedback loop right there. Core bleaching. So we've talked about this. Basically, what's going to happen here, they are very stressed in changes in conditions such as temperature, light, nutrients. They expel symbiotic algae living in their tissues, causing them to turn completely white. So pretty much they end up dying off. There are some species of coral that have been able to survive without the algae, and they are actually growing those in the laboratory, even down at Skidaway. There's a grad student doing that right now. But they're still concerned, like for instance, if we go back to, if we lose a lot of the forests on this page, we talked about this a little bit, then you're going to start increasing populations of insects and fungi that damage trees. So there's just a lot of concern about warmer winters leading to surges in the mountain pine beetle populations, and that's affecting the lodgepole pine forest, and those are dying off. So they're experiencing warmer winters, Yellowstone, their increased beetle infestations, and so that's going to affect the grizzly bears that feed on the white bark pine trees. So here are some changes in average ocean temperatures relative to coral bleaching threshold. This is past and projected. Regions in the farming may shift, decrease in tropical and subtropical areas because you're going to have it's going to be way too hot. It's going to become more dry. And you're also, it's going to increase northern latitudes. But, like I said, with those boreal forests that are melting, you might be thinking, oh, good, more farmland. Not the case. They do not have as much arable land. It's not as fertile. It's not as good to grow crops on. Another problem as we are shifting these tropics further and further away from the equator is, remember, this also is going to spread the Anomalous mosquito into a farther range, which means that there's a higher chance of getting malaria. And then you're going to have more GMOs that are more tolerant to the drought, and therefore we're not going to know what kind of long-term effects it's going to have on our health, and the amount of allergies that these GMOs put on the human body is unknown. Climate change will threaten health of many people. It's going to be hotter in some areas, so you're going to basically have deaths from heat waves increasing, but I guess on the flip side, you'll have deaths from cold weather decreasing. Higher temperatures cause increased flooding, increase in some forms of air pollution, more ground level ozone. Remember, not stratospheric, ground level tropospheric ozone is bad. It is bad for your respiratory system. There'll be more insects, more microbes, more toxic mold, and more fungi. I just went over some of those. So some governments are leading the way. Costa Rica, their goal is to be carbon neutral by 2030. And Norway aims to be carbon neutral by 2050. So Costa Rica, it basically generates 78% of its electricity is hydroelectric power. 18% is from wind and geothermal. So they use a lot of renewable energy for their energy sources. And then in Norway, they are also doing the same thing by using a lot of renewable energy. So what can we do? Remember, prevention is always cheaper than cleanup. So in order to decrease global warming, we need to cut fossil fuel use, especially coal. We need to shift from coal to natural gas. Natural gas is much cleaner. If we're going to have to use a non-renewable resource, we should be using natural gas. We need to improve energy efficiency. We need to shift more to renewable energy resources. We need to transfer energy efficiency and renewable energy technologies to developing countries, because now they're going through their industrial revolution and they're now outputting a lot of carbon dioxide. We need to reduce deforestation, use more sustainable agriculture and forestry, limit urban sprawl, reduce poverty, and slow population growth. Bottom two are easier said than done. For cleanup, remove carbon dioxide from smokestack and vehicle emissions, store or sequester carbon dioxide. Okay, so the next view here, the sequester, basically that means put it away. So for sequestering carbon dioxide deep underground, basically they want you to pump it underground or pump it into the deep ocean with no leaks. So that's a little trickier too. That requires energy. Repair leaky natural gas pipelines. Use animal feeds that reduce methane emissions from cows. So instead of feeding them corn, maybe they should be grass fed. A lot of governments are actually basically they're trying to encourage the use of renewable energy, but they'll basically put a tax on higher taxes on gasoline, and they promote the cap and trade. A lot of people think that the cap and trade, the cap is too high in the first place, so that they need to decrease that approach by decreasing the cap and trade, or to reduce or increase government subsidies to businesses that encourage the use of energy efficiency technology. And they're trying to use technology transfer so that the governments of developed countries help fund the transfer of the latest green technologies to the developing countries. That way we can help those countries deal with the effects of climate change. So these are all some solutions that you can think about. And these are just some projections of what would happen. This is, remember, the low end of that graph I showed you earlier. We hope to stay only at 2 degrees Celsius because If we get to a 4 degrees Celsius change in temperature, basically your parts per million here, 450 was where we're heading. But if you get up to a 650 part per million of carbon dioxide, it's never in the history of the world that we can see from taking the ice core data. We can see, remember, 400,000 years ago, and by looking at the gas bubbles in those ice cores, we see that it never in history before has it been greater than 300 parts per million carbon dioxide content in the atmosphere. And also, I forgot to tell you some other ways that they can see that this temperature has changed are from looking at the foraminophora. That is a hard-shelled protist that they find in the sea sediments. They look at this ice core data. They have been using satellite data. NASA's been tracking the temperature of the ocean and atmosphere since 1880, and never before has the temperature been as high as it is today, and has the carbon dioxide emission been as high as it is right now. So they're looking at all this data in hopes that people will see that we need to decrease our carbon output and our methane and nitrous oxide output, because we do not want more water wars. We're already starting to have those. We don't need more heat waves. We don't need water shortages. We don't need forest fires. We don't need glaciers to keep falling. I think this one's probably the most impactful because we're losing ecosystems, and we're going to have up here economic collapse and refugees.